14 billion years ago, something impossible happened. Nothing became everything. Before the universe existed, there was no space for things to be in, no time for things to happen. There was no up, down, before or after. It was a void, more empty than anything you can imagine. But then, in a fraction of a second, smaller than the blink of an eye, this nothing exploded and created all the space and all the time we know today. Scientists call this the Big Bang. But here's the mystery that keeps them awake at night. How can absolute nothing suddenly become something? And if nothing can create universes, could this be happening right now somewhere? Subscribe to the channel, leave your like and comment from what part of the world you're watching, because now I'm going to tell you everything. What does it really mean when we say there was nothing before the universe? Have you ever tried to imagine what nothing is? Most people think of nothing as an empty room, a blank picture, or a dark place with no lights or people. But when we ask about the very start of everything, scientists mean something even stranger than that. It is very hard to picture, but let us try to understand it together. When you walk into an empty room, you might say there is nothing inside. Maybe there are no chairs, no tables, no people. But the empty room still has space. There are still walls, a floor, a ceiling, and air all around you. You can still move, speak, touch things, or wait for time to pass. There are shadows, and maybe even a sound if you clap your hands. Even the darkest night, with no lights and no moon, still has space and time. In our daily life, nothing always means something is still there. Real nothing, as scientists use the word, is much harder to understand. In science, nothing means there is no space at all. There is nowhere for anything to exist or to move. There is no time, so nothing happens and nothing changes. There is no matter, which means nothing to hold, nothing to see, and nothing to weigh. There is not even a single bit of energy, like a tiny spark or a faint sound. It is not just empty, it is the total absence of everything. No air, no light, no darkness, no rules, no memories, and no space or time. It is not a blank page, because a page is already something. It is not even a vacuum, because a vacuum still has space inside it. It is something beyond all of these ideas, and that is very hard to imagine. Why is it so difficult to think about real nothing? The reason is simple. Every moment of our lives, everything we see and do happens in space and in time. Our whole world is made of things and spaces between them. When we look up at the stars, when we walk to school, when we talk to friends, it all happens somewhere, and it all takes some time. When you think of yesterday or tomorrow, you are thinking about time moving forward or backward. When you think about your room, a park, or another planet, you are always thinking about places and things in space. Our language and our thoughts are built for a world with space and time. We use words like before, after, here, and there. But if there is no space or time, these words do not fit. This is why thinking about nothing before the universe began is so strange to us. The question itself does not work the way other questions do. How can we talk about something that is outside of everything we know? Scientists try very hard to be exact. When they say before the universe, they mean before there was space or time at all. But even this is difficult, because to say before means that time was already moving, and outside means that space was already there. But with real nothing, there was no time to be before, and no space to be outside or inside. Imagine trying to describe a color that nobody has ever seen, or a feeling that nobody has felt, using only words from things you already know. This is what it is like when scientists try to talk about true nothing. No words truly fit. Still, Scientists try to get as close as possible. They use careful language and special ideas to help others see what they mean. Here is what we know. At the beginning, there was not even emptiness. There was no place for emptiness to be. There was no moment for anything to wait or happen. Every object, every second, every space or idea is missing from the picture. There are not even rules for how things can happen, because all rules we know need a universe to work in. Some people may ask, where was the universe before it started? Or, what was there before time? The answer is that there was not even a place or a time to be. Asking where or when does not work, because space and time did not exist. This makes the question very mysterious and hard to answer. Even with these strange ideas, scientists keep asking and trying to explain. They know that the universe is full of surprises. What we call nothing before the universe is not just empty space waiting for something to fill it. It is the complete absence of anything that can be touched, measured, or known. It is outside of everything we can ever see or feel. This is why the question, how did something come from nothing, is so hard. We do not have any ordinary experience with true nothing. We cannot visit it because there is nowhere to go. We cannot see or hear it because there is nothing to see or hear. Our minds and words cannot stretch far enough to grab the idea. But why does this matter? Why do people and scientists care so much about what came before the universe? It is because the mystery is so deep that it reaches the very start of everything. It is not just a question for science, but a question for anyone who wonders where everything comes from. If we could understand what real nothing is, then we might begin to answer how the universe itself could appear. Some people feel very unsettled when they hear there could have been nothing at all before the universe began. It is hard to imagine things just popping into existence without any reason or place. In all our experience, things must come from somewhere and must happen at some time. Nothing ever comes from nowhere. But in the deepest sense, before the universe, none of these rules may apply. Our world is filled with things caused by other things. Every sound has a wave. Every tree grows from a seed. Every river starts from a spring. But if there was absolutely nothing, then there were no things, no causes, and no results. The beginning of the universe asks us to imagine a reality where all of our normal ways of thinking do not work. It is normal to feel confused or even a little lost when you think about nothing in this way. Even many scientists find it strange and difficult. The words we use cannot really put the idea into shape. This is not because people are not smart enough, but because the idea is just so different from everything we know. Some people try to use pictures or drawings to help themselves. They might draw a blank page or a black space. But even these drawings show something. White or black, big or small. Real nothing is not white or black, not big or small, not heavy or light. It is not cold or hot, dark or bright. It is not any of these things, because these are all descriptions for things that are already in a universe with space and time. Now, you might wonder, if there was truly nothing, how could anything ever begin? If there was no time, how could anything happen? This is the root of the mystery. For the universe to come into existence, there had to be a moment, the first moment, when everything started. Space, time, energy, matter, and even the rules that make nature work. Before this, there was nothing, not a slow change or an invisible force, just total absence. Trying to talk about this beginning is part of what makes the question so hard. Every time we use words like first, before, or start, we are already using ideas that only make sense inside the universe. It is as if our minds are made for the world we live in and not for the strange idea of nothing at all. It can be helpful to think about why it is important to keep asking these questions, even if the answers are hard or seem impossible. Searching for answers can help us understand our place in the universe. It helps scientists learn more and more about how the world works. It helps everyone become more curious and thoughtful about life and existence. Some people might just accept that the universe began somehow, even if they do not know how. Others keep searching, hoping that someday science or new ideas will explain it better. For now, we can say that, in science, nothing means not just empty space, but no space at all. Not just no things, but not even a place or a time for things. It is the total absence of all that we know. This is why the question, "How could the universe come from nothing?" is one of the hardest questions anyone can ask. The idea of nothing is far stranger and more difficult than many people think. Yet, it is the starting point for everything else that science and philosophy try to understand about the world. When scientists study the start of the universe, they need to stretch their ideas to the limit. They try to make sense of a time when there was no time and a place where there was no space. This is not just a puzzle for experts, but a mystery that connects to the lives and questions of all people, young or old. Our world is full of things, and every day we move through space and time. From the moment we wake up, we are living inside this universe. A universe with stars, light, people, sound, solid ground, and the passing of seconds and minutes. But before all of this, when there was truly nothing, not even a second or a place, the rules were totally different. Even if we cannot fully understand what nothing means in this deepest sense, we can still try to get closer to the idea. We can remember that before the universe, there was not just darkness or silence. There was no place for darkness, no time for silence. There was the absence of all things, all places, and all moments. It is the greatest blank we can think of, and then still beyond that. This is what makes the question of the universe's beginning so wide and so fascinating. Every person who asks, "Where did everything come from?" is taking part in the search for answers. Some mysteries may always be too big for us to solve completely. But asking, trying, and learning is a big part of what makes people human. When you look at the night sky, when you wonder about why things are here at all, you are part of a long line of people asking the same deep questions. The meaning of nothing, as scientists see it, challenges us to think bigger and deeper than we ever have before. It reminds us that some questions do not have easy answers. Some ideas are so strange and new that all we can do is keep asking, thinking, and hoping to understand a bit more. That is why the idea of nothing is not just empty or blank. It is the key to the greatest mystery of all, how everything that exists now could come from a place, or a time, or a state where there was truly nothing at all. Even if we cannot fully imagine it, we can keep exploring step by step as we try to understand the real meaning of nothing. When people began to wonder about the beginning of the universe, they asked a very simple question: how did everything begin? Today, scientists think they have found a way to answer this question. They believe the universe began a very long time ago, in one special moment. This moment is called the Big Bang. According to science, the Big Bang was not like an explosion that happened in a certain place and time. It was much more than that. It was the beginning of all space, all time, all energy, and all matter. Scientists now say the universe started about 13.8 billion years ago. That is a very, very long time. When they talk about the Big Bang, they do not mean a fire or a burst in a room or a part of space. Before the universe existed, there was no space to explode into. Before the universe began, there was no time to say when anything happened. There was not even emptiness. The Big Bang was the birth of space and the birth of time. All the rules and things we know started right at this event. Right before the Big Bang, there was no place, no time, and no things at all. There was not even a tiny bit of energy or a single piece of matter. There was no form, no light, no darkness, no sound, and no silence. There was not even a pause, because time cannot pass before time exists. Then, in one instant, the entire universe began. Space itself started to appear. Time began to move forward. All the energy and matter that would ever exist in all the stars, all the planets, and every single atom was suddenly there. At first, in a tiny, very hot, and very dense point. After the Big Bang, the universe did not stay small. It began to stretch out and get bigger and bigger every moment. Space itself started to grow. Time began to move. Everything we know was born or made from this one moment. All the galaxies, stars, planets, air, sunlight, and even the cells inside your body can trace their beginning back to that first moment. Before the Big Bang, there was truly nothing. After the Big Bang, there was everything that would ever exist. This is very hard for many people to understand. Most people imagine explosions as loud blasts or big flashes. But the Big Bang was different. It did not happen in a location, because there was no location yet. It did not start in the middle of emptiness, because empty space had not been created. Instead, the Big Bang was the moment when the universe itself began. All points in space and all seconds in time started there. Scientists ask themselves, how do we know the Big Bang happened? The answer comes from looking at the universe and measuring it in many ways. When astronomers use special telescopes to look deep into space, they see light from faraway objects. Because light takes a long time to travel from those faraway places, seeing distant stars or galaxies means we are seeing what they looked like many billions of years ago. Light is like a message that travels across space, and it lets us see back into history. When we look in every direction, we see galaxies moving away from us. The more far away they are, the faster they seem to move. Scientists measure this with tools, and they see that the universe is getting larger and larger. Everything is spreading apart. This is true no matter which direction we look. This discovery tells us that long ago, everything must have been much closer together. If we follow this idea back in time, we find that there must have been a starting point. This starting point is what scientists call the Big Bang. Another clue comes from something called cosmic background radiation. This is a very faint glow of light that fills the entire universe. It is everywhere, all around, and it is very old. Scientists found this light with special machines. They believe that the cosmic background radiation is leftover heat from the early universe soon after the Big Bang. No matter where we look, we can measure this glow. It shows that the universe was once very hot, then cooled down as space got bigger. This is another reason why so many scientists believe that the Big Bang truly happened. The Big Bang idea also explains why the elements in the universe, like hydrogen and helium, have the amounts we see today. Right after the universe started, it was very hot and full of energy. As it cooled down, particles joined together to make atoms. These atoms first formed hydrogen and helium, the simplest and most common elements. By studying how much of these elements there is in space, scientists see that it matches what the Big Bang theory predicts. One of the strangest things about the Big Bang is that it is not just the start of all things, it is also the start of time itself. Before this moment, there was no before. The idea of before does not make sense because time did not exist. All the hours, days, and years we use to measure things began at the Big Bang. There was no way to count or wait before that moment. The clock of the universe started ticking when the Big Bang happened. Because time and space began together, questions like, what was there before? Or, where did it happen? Are not easy to answer. There was no place and no time for anything to happen. The Big Bang is a special kind of beginning that does not fit normal ways of thinking. Scientists have studied the universe in detailed ways to find more support for the Big Bang. They look for patterns in the temperature of the cosmic background radiation. They look for shapes and groupings in the way galaxies are spread out in space. All of these patterns match what the Big Bang theory says. Even today, the universe is still getting bigger. Galaxies are moving farther from each other every second. The space between them is stretching out. This means the story of the universe that began with the Big Bang is still continuing. Every part of the universe, from the most distant galaxy to the air around you, is part of this story. When scientists tell the story of the Big Bang, they also ask how we can know about things so old and so far away. The key is that looking far into the universe is like looking back in time. Light from very old stars started traveling long before there were people or planets. It moves across space slowly, taking millions or even billions of years to reach us. When we catch this light with telescopes, we are seeing messages from the deep past. These messages hold the clues about how the universe began. As the universe grew and changed, so did everything in it. But all of it started from the Big Bang, when space and time appeared. All the matter that would become galaxies, stars, planets, and even living things was packed closely together. At first, right after the Big Bang, the universe was extremely hot. There was nothing but energy and simple particles. As space expanded and time passed, the universe cooled down bit by bit. That allowed new things to appear. When people hear about the Big Bang, they often want to know what caused it. Why did the universe begin? This is still one of the deepest mysteries in science. The rules we use to think about how things begin do not work well without time, space, or things. Some scientists think there might be new kinds of laws that only work when space and time themselves are just beginning, but nobody knows for sure yet. Since the Big Bang, time has been passing. The universe is much older now than when it began. It keeps changing and growing. Every star and galaxy came from that first moment. The air you breathe and the light from the sun all share that beginning. The Big Bang is not just a moment in history, it is the starting point for everything we know. The idea of the Big Bang also gives us a way to think about how the universe works. Everything is made from the same basic matter and energy that appeared in that first instant. Over billions of years, matter came together to form stars, galaxies, and planets. Inside stars, new elements formed. Some stars exploded and spread those new elements into space. Over time, planets and people came from this process. But it all began with the Big Bang. The questions about the beginning do not stop with the Big Bang. They make scientists curious about what happened just after it. How did matter first appear? How did the universe go from simple energy to all the complicated things we see today? By studying the beginning, people hope to learn how everything changed and why the universe looks as it does now. Studying the Big Bang helps people answer more than just questions about science. It helps people think about their own place in the universe. It is not an answer that only experts can wonder about. Anyone can think about where everything started. The Big Bang theory is not just about distant stars and galaxies. It is about the everyday world, too. The evidence for the Big Bang is strong. We can see the universe getting bigger. We can measure the ancient light that fills space. We can count the amounts of simple elements and see that they match what would happen if there was a hot, dense beginning. The patterns in the universe, both big and small, all support the idea that everything started in one special moment. The Big Bang is not just a simple story from a long time ago. It is a way to understand how everything fits together now. The air, the light, the ground, the people, the stars, everything shares the same beginning. The Big Bang is a mystery, but it is a mystery that brings all things together. There are still many questions that nobody can answer yet. Scientists keep looking for more clues. They use bigger telescopes, improved computers, and smarter experiments. They share their results and studies. They ask each other questions and work together. Every new discovery helps provide another small piece of the puzzle. The Big Bang helps us see the universe as one. Every second, space is stretching out a little more. The mysteries of the beginning remind us that there is so much we do not know. Even so, the answers we have found give us a picture of how everything might have started. It is important to remember that the Big Bang started not just matter and energy, but space and time as well. The story of the universe is also the story of space stretching and time ticking forward. All the shapes, sizes, and ages began there. The idea of a beginning with no before and no where is new to most people, but it is what the science tells us. As people keep trying to understand how the universe began, they learn more about how the world works, but also about the limits of what we know and can explain. New ideas may one day help answer the questions that the Big Bang brings up. New tools and experiments may give more clues about what happened at the very start. While the Big Bang theory explains a lot, it does not answer every question. There are puzzles about what exactly happened in the very first moments. There are questions about what caused the Big Bang, if it was caused at all. The deeper scientists look, the more they realize how much there is left to learn. The story of the universe is not finished. Every day, scientists and thinkers continue their search for the truth. More evidence could appear, or new ideas could change the way we see things. Still, what is known so far tells a simple but amazing story. There was a time with truly nothing, and then there was a time when everything began. That first instant, that Big Bang, is at the center of how we understand the cosmos. People everywhere, no matter where they live or what language they speak, are part of this great story. The sky above, the ground beneath, every stone and every star, all come from the same beginning. The universe tells a story that joins everyone and everything. The Big Bang is an idea that helps bring the farthest past together with today. It makes us ask questions, search for answers, and wonder about more than just what we can see. It reminds us that there is a deep story behind the world we know. The search for how the universe began goes on, and every answer we find helps us build a bigger picture of where everything comes from and how it all fits together. After the first moment of the universe, when everything began with the Big Bang, many changes started to happen very quickly. The universe was not still or quiet. It was full of energy, light, and movement. From that one beginning, the universe started to transform little by little into the world we see today. These changes took a very long time, and they are still happening now. Every small part of the universe's early story helps us understand why everything looks the way it does. In the few first seconds after the Big Bang, the universe was very, very hot. The temperature was much higher than anything we can find anywhere now. There was no room for solid things or even normal atoms. The whole universe was filled with energy and tiny, simple particles moving very quickly. There was so much heat that nothing could stay together for long. Everything was crowded into a tiny space. Space itself was smaller, but it was growing every moment. Even though it is hard to imagine such heat and density, scientists can guess what happened by studying light and matter today. When the universe was this young, the only things that existed were basic particles. There were tiny bits called quarks and electrons, and also light moving everywhere. These basic particles are the building blocks of everything. For a very short time, the universe was like a sea of energy and particles with no shape, no stars, and no atoms. As the universe grew, it also started to cool down. This cooling was important. When the universe cooled, particles slowed down and could start to join together. After a few short minutes, the first big change happened. Quarks joined together to make protons and neutrons. These are two of the main parts needed to build atoms. Once protons and neutrons formed, the next step could take place. About 3 minutes after the Big Bang, the universe had cooled enough for protons and neutrons to combine and make simple atomic nuclei. Most of these were forms of hydrogen and helium. These two elements are still the most common types of matter in the universe, even now. There were also some tiny amounts of another element, called lithium. Inside the universe at this time, almost all matter was these three things: hydrogen, helium, and a little lithium, all moving in a hot, bright soup. But normal atoms, the kind that build all things around us, were not yet ready. It would take much longer before the universe cooled enough for electrons to join the atomic nuclei. For the next hundreds of thousands of years, the universe kept getting bigger and cooler, but it was still too hot for light to travel far. The universe was filled with particles, but everything looked like a bright fog because light always bounced off free electrons. Then, after about 380,000 years, another big event happened. The universe finally cooled down more, and electrons could join up with the atomic nuclei, at last forming whole atoms. This moment is very important. Now, light could move mostly without getting bounced back and forth. The universe became clear instead of foggy. This is the time when the cosmic background radiation was released. It is the old light that scientists still measure today to learn about the early universe. With the universe now clear, light could travel for the first time across empty space. Space was still filled almost entirely with hydrogen and helium gas. There were no stars, no planets, and no people, but matter was finally able to move and join together because space was no longer filled with thick, hot fog. Once light could go far, matter could collect into slightly denser areas. These were small differences in the amount of matter in different places. Over millions of years, gravity began to pull matter closer together in some regions. Slowly, very slowly, the first clumps of hydrogen and helium grew. The force of gravity kept making these clumps tighter and denser. Over hundreds of millions of years, the dense clumps of gas became hot again in their centers. When the centers became hot and dense enough, nuclear reactions started. These nuclear reactions gave birth to the first stars. For the first time, the universe was filled with points of bright light made by new stars burning hydrogen and helium. Stars are very important for the story of the universe. Inside stars, special processes happen. Stars are like factories where new elements are made. At first, the universe had only hydrogen, helium, and a little bit of lithium. But inside stars, pressure and heat can make more kinds of atoms. Over time, the centers of stars can create new elements like carbon, oxygen, and iron. When some large stars come to the end of their lives, they explode and send these new elements out into space. That is how space gets filled with all the elements needed for planets, water, rocks, and living things. Galaxies also started to form as groups of stars came together. Gravity held stars in big, swirling collections. These giant collections of stars are called galaxies. Each galaxy can have billions or even trillions of stars. Our own galaxy, the Milky Way, began to take shape long after the first stars were born. The process that led to galaxies, stars, and planets took a very long time. After millions and millions of years, there were many galaxies of different shapes and sizes. They were spread out widely as the universe's space was expanding the whole time. Some galaxies were closer together, some were farther apart. Scientists look at how these galaxies were formed to learn about the past and how matter moved after the Big Bang. Stars within galaxies also have their own stories. Some of the first stars were huge, short-lived, and burned out quickly. When they exploded, they spread heavy elements into space. This made more material for future stars and for planets. As more and more stars lived and died, the universe slowly got more complex. More elements appeared, and with them, new types of things became possible. After billions of years, the universe was not just a place of hydrogen and helium. Now it had carbon, oxygen, nitrogen, silicon, iron, and many more elements. These are the ingredients needed to make planets, moons, water, rocks, and someday, life. Slowly, small bits of dust and gas collected around new stars to form planets. These planets were spinning balls of rock, ice, metal, or gas. Some planets were very hot, some were very cold. A few planets, like our Earth, would one day become homes for life. But for a long time, the universe was still almost empty compared to what we see now. To understand this long story of change, scientists use telescopes to look very far into space. When they look at galaxies that are far away, they are seeing what those galaxies looked like billions of years ago. Light from far away takes a long time to reach us, so looking at far places is like seeing into the past. This lets scientists map out the history of change in the universe, from a hot, bright, dense beginning to the huge, cool, organized universe we live in now. When scientists study how the universe changed after the Big Bang, they use light as a kind of message from the past. They also look for chemicals in distant stars or in the space between galaxies. By measuring how much hydrogen, helium, and other elements are present, they can see if it matches what should have happened after the Big Bang. These studies always show the same thing. The universe really did start hot, full of energy, and then grew and cooled, making more and more complex things. All the stars, galaxies, and planets share the same root in the Big Bang. The steps from energy to small particles, from particles to atoms, and from atoms to stars took millions and billions of years. The universe keeps expanding, and even now, new stars and new galaxies are born all the time. The changes that started long ago are not finished. The story of change is still happening. Every person, every stone, every drop of water, and every living thing comes from the same atoms made in stars long ago. The processes that happened after the Big Bang, where simple things became complex, led to everything around us. The air we breathe, the light from the sun, and the ground beneath our feet all have roots in those old processes. The changing universe is not just a story told by scientists. It is the story of everything. By studying how the universe changed after the Big Bang, we learn more about why things are the way they are. Why do we see stars and planets? Why does light travel so far? Why do we find the same elements on Earth that we find in distant space? All these answers come from understanding how the universe grew and cooled. Looking at distant galaxies and stars gives us a picture of the changes that happened. Scientists can measure how fast galaxies are moving away from us and from each other. They see that the universe is still getting bigger. They see, too, that the oldest galaxies look different from the new ones. The oldest stars are simpler. The youngest stars are more complex with more elements in them. This matches what scientists expect from a universe that started simple and slowly changed over a very long time. Today, the universe is much cooler and larger than it was just after the Big Bang. But the process of change continues. Stars still form new elements, galaxies move, and space stretches. These changes started in the beginning and have never stopped. When we look at the night sky, every star is like a message from the past. The light we see from some stars left them thousands or millions of years ago. The light from the oldest galaxies started its journey not long after the first stars formed. The universe's past is written in the light and matter we can detect right now. Scientists sometimes use computers to build models that show how the universe changed over time. They put in all the data from telescopes and measurements of galaxies, light, and elements. These computer models help check if our ideas about the early universe are right. The results almost always agree. The universe started out hot, dense, and full of energy, and over time became the huge, cool, and complex universe we see now. The expansion of space still continues today. The distances between galaxies grow bigger as more time passes. This means that the universe will keep changing for a very long time. New stars will be born, old stars will die, and the elements inside them will become part of new stars and planets. All these changes began with the events right after the Big Bang, when the universe first started to take shape. Every piece of evidence, from light in the cosmos to the elements we find, tells the same story of change. The universe has a history of becoming something new. It changed from energy to particles, from particles to atoms, from atoms to stars, and from stars to galaxies and planets. Each change made the universe a bit more complex and ready for other things to appear. Today, people still study the universe's history. They ask how the very first changes happened and what the universe looked like after the Big Bang. They search for clues in the oldest light and matter. Every new answer helps us understand more about the world we live in. The changes that happened after the Big Bang and that still go on now are part of a bigger story. The universe is not finished. It keeps making new things and new places. From the first instant of energy and tiny particles through the long cooling and growing up to the stars and galaxies we see, the story is always moving forward. Understanding how the universe changed after the Big Bang helps to explain why we are here today and what kinds of things might still happen in the future. It brings together the history of stars, matter, light, and even our own planet into one big story that started almost 14 billion years ago and continues every moment. As the universe continued to grow and change, many new things became possible. Stars and galaxies started to fill the space that had once been only hot, bright, and simple. At the same time, there were still many mysteries about how everything had started. People were able to explain much of what happened after the first moments. They saw how matter formed and how stars were born from clouds of gas. But the question of the very beginning was still the hardest to answer. The challenge that makes the first moment of the universe so difficult to understand is that normal science does not work in the same way at the very beginning. If you look at how stars form or how galaxies group together, you can use the laws of physics. These are rules like gravity, which pulls objects together, or thermodynamics, which talks about heat and energy. For most things in the universe, these rules explain how things happen. You can make models and write down equations. You can do experiments. But for the very first moment, when nothing became everything, these rules may not be enough. This is strange for people who are used to understanding cause and effect. In daily life, things always happen for a reason. Water boils when it gets hot. Plants grow because of sunlight. Stones fall when you drop them. Everything has a cause, and we can use science to explain these causes. When scientists try to look back to the first moment, To the instant when the universe began, cause and effect seem to break down. This makes it hard to explain what started the universe or why it began at all. The laws of physics we use now were created by looking at the world around us. Every rule and formula we know was built by studying places and things inside the universe. But these laws were made after the universe already existed, with time and space in place. When there was no space and no time, it is hard to see how the same rules could work. For example, gravity only has meaning if there are things to pull together. Light and energy only move if there is space to move through. People ask, if physics does not work the same way at the beginning, how do we even study it? Scientists want to know what happened at the first instant, but they need new ideas and possibly new laws. To do this, they look at what happens inside places where normal physics stops working. One such place is called a singularity. This is a point where gravity and energy get so strong and so dense that old rules seem to break. For the universe, the Big Bang itself is thought to have started from a singularity. A singularity has no size or shape that we can measure. The numbers for density and energy become so high that our math gives strange results, like infinity. In everyday life, nothing is infinite. But at a singularity, the usual ways of counting, measuring, or explaining things stop working. This is why it is almost impossible to describe what was there or what happened without using ideas that are different from our normal experience. One of the greatest challenges is that time itself began with the universe. Before the universe, there was no time. That means it does not make sense to talk about before the Big Bang. The question, what happened before, is not just hard, it may have no meaning, as there was no time yet for anything to happen. Some scientists try to use math to describe what the first instant was like. They write equations that follow the shapes and rules of space and time, but even good equations may not be able to reach all the way back. Some equations break down and stop making sense right at the beginning. This is called the limit of our scientific understanding. If our math does not work for the first moment, we need something new. There are other problems too. Inside the universe, light has a certain speed. Nothing moves faster than this speed. But during the very first moments, the universe expanded so quickly that space itself stretched much faster than anything we see now. That kind of rapid growth is hard to describe using old physics. This special time is called inflation. During inflation, tiny changes in energy may have grown into the huge and complex universe we see today. Some scientists believe that the answer to the first moment lies in a new kind of science called quantum physics. Quantum physics studies the smallest things in the universe, smaller than atoms. It describes how small bits of energy and matter appear and disappear for very short times. At these small sizes, things can happen in ways that are very different from normal life. For example, things can be in more than one place at the same time. Causes and effects can seem mixed up. In quantum physics, sometimes things simply happen with no clear reason. If the birth of the universe used these quantum rules, then the very first moment could be more strange than we imagine. Some ideas say that the universe came from a quantum fluctuation, a small, sudden change in nothingness that made something appear. Other ideas say that time and space themselves are made from even smaller, more basic things, and that these basic things have their own strange laws. To explore the beginning, scientists try to join two parts of physics: the study of very big things, called general relativity, and the study of very small things, called quantum mechanics. These two sides of physics work very well for most of the universe, but they do not fit together at the Big Bang. General relativity tells us how gravity shapes stars, planets, and the motion of galaxies. Quantum mechanics tells us how atoms and particles move and change. But when everything is squeezed together at the Big Bang, Both ideas must work at the same time. No one yet has found a way to combine them fully to describe the first moment. Another hard question comes from thinking about energy. In our world, energy is always counted. It can move from place to place or change from one kind to another, but it cannot be created or destroyed. This law works for everything we know. But in the very early universe, energy and matter may have behaved in new ways. When the universe began, all the energy and matter that would ever exist in the universe may have appeared at once. Scientists want to know how this is possible. Does something outside the universe cause it? Or is it possible for energy to borrow itself from nothing? These are not easy questions, and science has not yet found the final answer. Scientists know a lot about what happened after the first moments. They understand how atoms formed, how stars and galaxies took shape, and how matter cooled and spread out. But the story of the very beginning, the true cause of the Big Bang, remains one of the deepest mysteries. It is a puzzle with many missing pieces. To get closer to the answer, scientists study hints they find in the universe today. They look for patterns in the oldest light, in the way galaxies are spread out, and in the amounts of different elements. Every detail is a clue, but at the same time they know the evidence might be limited because the first moment is hidden in the very rules of time and space. One idea is that the laws of science as we know them changed at the very start of the universe. Maybe the rules we use now did not even exist back then. This is possible if space and time themselves are things that began at the Big Bang, not things that always existed. In this view, asking why or how the universe began is not the same as asking why a tree grows or why a star shines. It is a different type of question, one that needs new ways of thinking. There are many ideas about what could have happened. Some people suggest that the universe came from a process that repeats, meaning there could have been other universes before ours, each with their own beginning and end. Others say that the universe is just one of many, a multiverse. In each universe, the rules might be different, and we just live in the one where things turned out the way we know. With so many ideas, it might seem confusing. But all scientists agree about one thing. The beginning of the universe was very special, and the normal tools of science are tested to their limit when we look at it. Every year, new models and better math are made to try to go further. Some models use computers to guess what would happen with different rules or at smaller sizes. These models help scientists to see possible ways the universe could have started, even if they cannot prove which way is right. The beginning of the universe also tests our ideas about what is possible. In normal life, things only happen if something makes them happen. In the very first moment, it seems like something happened from nothing without a normal cause. This is why many people find the question so strange and hard to accept. Some say it is possible that the universe just began with no outside reason or force. There are also philosophical questions. Some thinkers ask if our language and ideas are strong enough to explain the beginning. If everything we know happens in time and space, but time and space started with the Big Bang, maybe words like before, cause, or start are not really useful for this mystery. In this way, even the best scientists and thinkers are trying to go past the limits of words and begin to use new ideas or even silence to talk about the beginning. Some people turn to new branches of math, making up special ways to count or measure things that do not need time or space. Others work on ideas called string theory, where the smallest bits of the universe are tiny strings or loops that vibrate at different speeds, maybe giving rise to everything else. These ideas are very new and not yet proven, but they help us think about how the universe could have come from nothing. The challenge of explaining the first moment is a unique puzzle. No controlled experiment can visit the time before space and time or recreate the Big Bang in a laboratory. Instead, scientists build bigger and better tools to look far away and far back in time, hoping to see clues in the oldest light and matter. Every small bit of new evidence helps. Sometimes a new piece of light from space or a new pattern in the background radiation gives a fresh clue. Sometimes, computers running for many days on special equations show a possible map for how the universe may have begun, but there is not enough proof yet to pick the one right explanation. Science keeps pushing forward little by little, asking harder questions and thinking in new ways. The hope is that by studying more, collecting more data, and improving the math, a clearer picture of the beginning will come into view. Even though there are still many puzzles, most scientists agree on what happened after the universe began. They agree that time and space started at the Big Bang, and that the universe has been expanding, cooling, and changing since the beginning. But when it comes to why or how the first moment truly happened, the answers are still out of reach. The story of the universe's first moment teaches us that there are some questions where our best tools and ideas reach their limit. Sometimes there is not yet enough information or a good enough theory to answer, but that does not stop the search for answers. Driven by curiosity, scientists keep studying, measuring, and building new ways to learn. This great mystery is important not only for science, but for anyone who wonders about life, existence, and the world itself. The beginning of the universe touches on everything we know and everything we will learn in the future. Each step in this search for answers leads to new questions. And so the journey continues as people try to understand where everything came from and how anything at all can begin. Curiosity drives people to look for answers, especially when questions are so big and mysterious. When scientists reached the limit of what old ideas and usual ways of studying could show, they needed something new. To explore the beginning of the universe, scientists began to use special kinds of mathematics and create theories with these mathematical ideas. These are called theoretical physics and advanced mathematics. They help people go beyond what can be seen and touched. Theoretical physics is a way of describing the universe by using numbers, shapes, and logical steps. With mathematics, scientists can write down the rules of nature, even for things that are too small or too far to be seen. Very often, the universe follows patterns that can be written as equations. An equation is a sentence made of symbols that shows how different things in the universe are connected. Many great discoveries in physics have been made by thinking about these patterns first, then testing them later. To talk about the beginning of the universe, scientists use mathematical tools that are very complex. For example, they use the math of general relativity. This is a theory created by Albert Einstein. It explains how gravity works, not just between planets but also in the whole universe. The rules of general relativity show how space and time are connected and how matter makes space stretch and bend. But these rules work best for big things like stars, planets, and galaxies. There is also quantum mechanics, another kind of math that explains how very small things behave, like atoms and the particles inside them. In quantum mechanics, particles can do things that seem impossible. A particle can move in strange ways, disappear, or change its state in a way that cannot be guessed by regular rules. To understand the beginning, scientists need something even more powerful than either of these on their own. They must try to put both general relativity and quantum mechanics together. This is very hard because the two types of mathematics do not always fit together in a perfect way. Still, scientists keep trying to join them because the earliest moments of the universe are a place where both big and small effects are important. With these mathematical tools, scientists make models. A model is an idea about the universe, usually written with equations. The model can be used to predict what the universe should look like now if it started in a certain way. Scientists test their models by checking whether the predictions match things we see, like the way galaxies are spread out or the light from far away. Some models try to show what happened a split second after the Big Bang. Others try to imagine what the first moment was like. Some even try to guess if there are other universes or if the rules of nature were different at the beginning. The mathematics can become very complicated. Sometimes, when scientists solve their equations, they find answers that do not make sense by normal experience. For example, the math might show a place where space has no shape or time has no direction. This tells scientists that our ideas are not always enough and that new physics might be needed. Writing the equations is only the first step. To use them, scientists must solve them and look at the results. Many equations have no simple answer. Some need powerful computers to do the calculations. Sometimes, computers run for many days or weeks, checking each small step. Only after seeing what the equations show can scientists compare the results with what exists in the sky. Testing a theory is very important. In science, no idea is accepted just because it is possible to write it down. To be sure, scientists check if the model agrees with what is real. For the Big Bang, this includes looking at the oldest light, the background radiation left from when atoms first formed. If the math can explain the patterns in this ancient light, that is a good sign the theory is correct. There are also other things to look at, like how galaxies are shaped and how fast the universe is growing. Each new piece of information can help check if the mathematics is right. If not, scientists change the model or look for new ideas and equations. One important part of theoretical physics is thinking about things that are too far or too early to measure directly. Because nobody can go back to the very beginning, mathematics becomes the tool for exploring what cannot be reached. This is one reason mathematics is so important in understanding the universe. It lets us stretch our minds and see what might have been even when we have no way to observe it directly. Sometimes, the answers from these equations are very strange. For example, the math might show tiny leftover energies filling empty space. These are called quantum fluctuations. These tiny changes can affect how things start. Some scientists believe that the universe itself might have begun from a quantum fluctuation. In this idea, even if there is no space and no time, these tiny changes can appear for a very short time. Sometimes they make something new happen. Scientists use mathematics to make predictions, but they also try to find new laws that join the old ones. One idea is called quantum gravity. This is a possible new set of rules that would describe both gravity and the small world at once. Scientists do not have a final version of this yet, but they hope one day to find the right equations. If they succeed, the new rules could explain the first moment of the universe in a way that makes sense. Another mathematical idea is string theory. In string theory, all the tiny bits that make up the universe are not just points, but tiny loops or strings that move and vibrate. The way these strings move decides what kind of particle or force they become. String theory uses very advanced mathematics and many extra dimensions beyond normal space and time. It is a very hard theory to test with experiments, but it is one of the best hopes for making all of physics match together. Some models from mathematics try to explain how space and time themselves could grow out of nothing. These models often use equations that show how one kind of state with no space or time changes suddenly to another, where space and time exist. In these ideas, the laws of math are not just describing the universe, but actually making it appear. Computers are very important for theoretical physics and mathematics. Many of the models scientists use are too hard to solve with just pencil and paper. Computers can test trillions of possibilities very quickly. They help by finding which models can lead to a universe that looks like ours. By changing small parts of the models, scientists can see what happens if the rules were different. When scientists use computers and mathematics together, they can make simulations. A simulation is like a pretend universe inside the computer. By starting the simulation with the math rules of the Big Bang, the computer creates a model that shows how the universe would look over time. Scientists watch what happens in the simulation, how stars form, how galaxies change, and how matter spreads out. They then check if these things are the same as what we see in space. If they are close, it means the theory might be correct. Mathematics can sometimes bring surprises. There are answers that were not guessed before. For example, the equations might show that the universe would expand forever, or that it could stop and shrink, or that it could go on to make others. In mathematics, each small change to a rule changes the story of the universe. This is how science learns not just what did happen, but also what might have happened under other conditions. One problem that comes up in theoretical physics is that not all ideas can be tested with real experiments. Some models are very hard to prove or disprove because nobody can see what happened at the very beginning. In these cases, scientists use other methods to check if the idea is reasonable. They might look at what would happen if the laws are applied in a different way. If the ideas do not match what is seen in the real universe, this means the model is probably not correct. Equations and theoretical physics also help to explain details about things like the cosmic background radiation, which is the oldest light we see. This light has small changes across the sky, and these changes carry a message from the early universe. The patterns in this light match what is expected from certain kinds of math. This gives support to the models that use these equations. Scientists from all over the world work together and share their work in theoretical physics. By building on each other's ideas, they hope to find a theory that describes the whole universe, from its smallest particles to its largest galaxies. Many times, different teams will test different equations to see which ones make good predictions. This teamwork means new ideas are always being discussed and checked. To keep moving forward, scientists also invent new mathematics when the old mathematics is not enough. For example, some areas in the early universe may have changed too fast for old math to describe. Scientists make new ways of counting or new types of logic to show how the universe could have changed so quickly. These new mathematics help open new paths to understanding. People sometimes think of mathematics as just numbers, but for science, it is a language for everything. It is a tool for making predictions about what will happen, for explaining patterns that can be seen, and for asking what could happen if things were different. In searching for the answers to the beginning of the universe, mathematics and theoretical physics are some of the most powerful tools that people have. With every new model and equation, the search for the beginning continues. Each tries to answer the question, how was it possible for the universe to start from nothing? Each tries to show what the laws might be for something so strange and far away from normal experience. Even though many questions remain, scientists use these tools to get closer with every new discovery, every new number, and every new idea. The use of mathematics is not just for understanding what happened a long time ago, it is also for thinking about what might happen next. Scientists use their equations to ask if the universe will keep growing forever, or if it might slow down. They use their models to see if new universes could be made from old ones, or if the rules of nature could ever change. These questions, like the questions about the beginning, use mathematics as the key. Every time scientists build a new telescope or a new computer, they use theoretical physics to decide what to look for and how to test their ideas. When new information comes from space, such as light from far away, they use mathematics to check if it matches what the models say. If it does not, then something new must be learned and the equations might need to be fixed. The partnership between mathematics, theoretical physics, and what can be measured is what makes the search for the beginning of the universe a journey. This journey goes forward each time a new piece of data is found, each time equations are solved, or each time computers test a new possibility. Sometimes scientists have to wait many years for a single answer. The search is slow, but every step is important. Every equation solved and every model tested is a step closer to understanding where everything came from and how something can come from nothing at all. Mathematics is a powerful light for the mystery of the beginning. It leads the way into places that nothing else can touch. Even when the questions are hard, and even when proof is out of reach, the use of mathematics and theoretical physics gives hope that one day the first moment of the universe can be understood. As scientists use mathematics to look for answers about the beginning, they also use another way to learn more about the universe. This way does not use only mathematics or computers, but also special instruments that can collect light and information from very far away. By combining all these ways, the search to understand the universe grows stronger and deeper each day. As scientists build new tools to discover more about the universe, they realize that learning about the beginning is not just about mathematics and computers. It also needs careful observation. By looking out into space, scientists can learn about events that happened billions of years ago. This is possible because light travels at a certain speed, not instantly. When we look at distant parts of the universe, we are seeing them as they were long ago, not as they are now. Light is a message from the past, carrying information across empty space. Telescopes are special instruments that help us see much farther than our eyes can. Some telescopes are on the ground, and some are sent into space. Scientists use them to gather light from stars, galaxies, and other objects. The bigger and better a telescope is, the further and clearer it can see into space and time. Telescopes come in many shapes and sizes. Some collect visible light, which is what people can see with their eyes. Others gather waves like radio, infrared, ultraviolet, or even X-rays or gamma rays. Each type of light tells a different part of the universe's story. A key idea that helps scientists study the past is that the farther away a star or galaxy is, the older the light is by the time it reaches us. For example, if a star is 10 million light-years away, its light left the star 10 million years ago. When we see that star today, we are seeing how it looked in the past. If a galaxy is billions of light-years away, its light shows us the universe as it was when it was very young. By collecting this old light, scientists can map out the history of the universe. They can see how galaxies formed, how they changed, and how the universe grew over time. Looking farther away is like looking deeper into the past. The earliest parts of the universe can only be studied by finding the oldest and farthest light. One of the most important kinds of light is the cosmic background radiation. This light is very, very old. It comes from when the universe was only about 380,000 years old. At that time, atoms first formed, and light could travel freely across space. Before this moment, the universe was too hot and dense, and light always bounced around and could not travel far. But then the universe became clear, and the oldest light began to move across space. The cosmic background radiation is not bright and easy to see. In fact, it is very faint. It fills all of space and can only be detected by special instruments. Scientists first discovered it when they were studying radio waves. Now, they use special satellites and big telescopes to measure it very carefully. The study of this ancient light tells us a lot about the very early universe. It helps prove that the Big Bang happened and shows how the universe was at the very beginning. Measuring the cosmic background radiation is not simple. It is almost the same everywhere. But careful instruments show that there are tiny changes in the temperature and strength of the light, depending on the direction we look. These changes are very small, but they are very important. They show how matter was spread out in the early universe. These tiny differences helped lead to the first clumps of matter, which later became stars, galaxies, and planets. These patterns in the cosmic background radiation are like a picture of the universe when it was very young. By studying them, scientists can tell how much matter, energy, and even what different types of matter were present at that time. These measurements help test mathematical models about the universe's beginning, and they match what is predicted by the Big Bang theory. Telescopes do not only help us see the cosmic background radiation, but they also let us find very old galaxies and stars. Some telescopes can discover galaxies that formed only a few 100 million years after the Big Bang. These are the oldest galaxies that anyone has ever seen. Each time a new, better telescope is made, scientists can see farther and collect older light. Finding these ancient galaxies is not easy. Their light is very faint and sometimes has been stretched by the growing universe. This stretching is called redshift. It means the light from very far away becomes more red the further it travels. By measuring redshift, scientists can tell how far the light has traveled and how long ago it was made. The discovery of these old galaxies shows how the universe changed over time. Scientists count how many galaxies there are, what shapes they have, and how they move. From this, people learn about how gravity drew matter together and how the first stars came to be. Sometimes, very large and powerful telescopes are pointed at one small patch of sky for many days just to collect enough light from these distant and ancient places. As telescopes gather light of different types, they also learn more about changes that happened in the universe. For example, by looking at the way light is blocked or changed by clouds of gas or dust, scientists can find where new stars are forming. They can measure how fast galaxies are moving and see how the universe is still expanding. In every direction, almost all galaxies are moving away from us. This agrees with the idea that the universe started from a small point and has been growing ever since. Another thing telescopes help scientists measure is how much simple gas, like hydrogen and helium, is in different parts of the universe. By checking how much of each type of atom is present, scientists see if the numbers match what would happen if the Big Bang theory is correct. These numbers always agree with the predictions, which is more proof for the model of the beginning. New technology makes telescopes much more powerful than before. Today, there are very large telescopes on high mountains and in the desert. There are telescopes in space, above the air of Earth. These space telescopes can see light that is blocked by the Earth's air, opening new views of the universe. People in many countries work together to build these instruments, share what they find, and help each other answer the biggest questions. Telescopes need computers too. When scientists collect so much light and data, they use powerful computers to organize and study it. Computers make pictures from the data, help measure tiny changes, and show how galaxies change shape. With these tools, people can turn old light into new knowledge, finding clues about the start and history of the cosmos. Not all telescopes look like what people imagine. Some are huge mirrors that collect light on mountaintops. Some are long dishes that listen to radio waves. Some are balloons or planes with sensitive detectors. Some are even small satellites that orbit far from Earth and collect kinds of light that cannot reach the ground. Each kind of telescope teaches us something different. Infrared telescopes see heat from cold clouds in space, where new stars are being born. Radio telescopes find signals from gas between galaxies and from very strange things like exploding stars or fast-spinning objects. Gamma-ray telescopes catch the most powerful explosions in the universe. Together, all these tools help build a full picture of how everything has changed since the universe began. By using telescopes, scientists can also test ideas and mathematical models. Every new discovery lets people check predictions, measure how fast changes happen, and explore new puzzles. If a model does not match the light and data from telescopes, then scientists know they need to ask new questions or come up with new ideas. Sometimes, discoveries surprise people. Light from far parts of space might show a new kind of object, or a pattern in the cosmic background radiation might not fit what was expected. When this happens, people look even more closely, build better instruments, and check their work again and again to be sure. This is how science makes progress and avoids mistakes. Studying light from space does not just show how the universe looks today, it also shows how it used to look. Galaxies closer to us are more mature, while galaxies that are very far away are younger. By looking at many galaxies at different distances, scientists can see the whole process of how stars, galaxies, and planets formed and changed over billions of years. In addition to looking far away, scientists sometimes use telescopes to look back in time by studying things that act like fossils. These are the oldest rocks, the simplest stars, or places where light from the beginning is trapped. Each one adds one more piece to the puzzle of the universe's story. Even though telescopes have revealed a lot, there is still more left to discover. Some parts of the universe are hidden behind dust or are too far for any current telescope to see. Some kinds of light are so faint that it is very hard to collect them. Because of this, people are always trying to make better instruments and new methods for finding even the weakest signals. Working with telescopes is not something one person does alone. It takes teams of hundreds or thousands of people working together across countries and languages. They plan where to look, share results, fix problems, and celebrate when new discoveries are made. The information from telescopes leads to new questions. Sometimes it shows strange surprises, like galaxies that are bigger or older than expected, or stars that form faster than scientists thought possible. Each new question is a chance to learn more and think in new ways about the universe's past. The search for the oldest light and farthest galaxies continues to push the limits of technology. Scientists dream of seeing even closer to the beginning, catching the first flashes of light and finding out how the first atoms and stars and galaxies grew up. Every advance in telescopes and computers brings the answers a little closer. Looking back in time with telescopes is like reading a story written in light. With every observation, another part of the story is revealed. As people gather more and more light from the sky, they learn about what the universe was like in each era, from the hot, bright start through countless changes up to the present day. Scientists know that as they collect more information, the picture becomes clearer. Bits of light from every direction help make a map of space and time. This map lets people follow the universe's changes and see how simple forms became complex, how empty space filled with stars, and how matter came together to make all the things we know. With every new discovery, scientists are reminded of how big, beautiful, and mysterious the universe is. The oldest light, the farthest galaxies, and the tiniest particles all connect together to tell the same story. The universe is growing, changing, and full of surprises. All of this searching and measuring leads to deeper questions. People wonder if there could be other ways for the universe to begin, or if the laws of nature might allow for different possibilities. These questions are not easy to answer, but each new clue found with telescopes is a step towards better understanding. Working together, using both mathematics and careful observation, scientists hope to find answers about the start of everything. The combination of seeing and thinking, measuring and testing is at the heart of the search for the universe's origins. As technology grows, so does the ability to look deeper into space and further into time. Scientists all over the world share what they learn, hoping to put each new discovery into the bigger story. The journey of light from the beginning of the universe continues to guide people in the search for how everything started and what the first moments might have been like. Thinking about how far the search for knowledge has come, it is clear that every measurement and every picture from a telescope brings more understanding. It helps explain not just the numbers and the science, but also the wonder and excitement of living in a universe with such a deep and mysterious past. Science goes forward step by step, using every tool that people can build, every law that mathematics reveals, and every faint signal from the ancient universe. The answers that come from all of this searching are not just facts, they are the key to understanding why the universe is here and how it keeps changing. Each observation leads to more questions and new ideas, keeping curiosity alive as people explore the greatest mystery of all. As astronomers and scientists gather more information from telescopes and use mathematics to describe what they see, the search for how everything began becomes even more interesting. Each new discovery raises new questions. One question is especially important. How can something come from nothing? This question is not easy to answer. Scientists have different ideas about what might have happened at the very start of the universe, and they keep working to understand this great mystery. Some scientists think that even in a place with no matter, no energy, and no space, there can still be small changes. These changes are called quantum fluctuations. In quantum physics, very tiny things can appear and disappear for a very short time, even in what people call empty space. Some scientists suggest that a quantum fluctuation could have started the universe. In this idea, the universe began as a very small change in the vacuum, which is a place with no things at all. For one moment, this small change grew and became everything we know. Quantum fluctuations are based on the rules of quantum physics. These rules are not like the rules people use every day. In the quantum world, things do not always have a clear cause or time. Things can happen in ways that look random or without any reason. This means that the whole universe could maybe begin because of a tiny random event with no cause from outside. Other scientists have different ideas. Some wonder if there are many universes, not just one. They suggest the idea of the multiverse. In the multiverse idea, there are many different universes, each with its own space, time, and laws of nature. These universes could start in different ways. Our own universe is just one out of a huge number. Each one could have different rules. Some universes might be very strange, and some might look almost like ours. But each one, including ours, could begin from its own version of nothing. In the multiverse idea, it is possible that quantum fluctuations happen in many different places or at many different times. Each fluctuation could grow into a new universe. This means the Big Bang is not the only beginning, but one beginning among many. This idea cannot be tested directly yet, but it helps scientists think about more possibilities. Another idea is that space and time themselves are made from smaller things we do not understand yet. Some scientists use mathematics to think about tiny structures or patterns that make up space and time. These could change or move in special ways, leading to the start of a new universe. The beginning, then, is a sudden change in the way space and time are put together. This change could be the first moment, when there was nothing just before and something right after. Some scientists use theories like string theory to describe what might happen at the start. In string theory, the most tiny pieces of nature are not small balls, but tiny vibrating loops called strings. The way these strings vibrate decides what they become. Some might become particles of light, some might become forces, and others might become bits of gravity. By describing how strings can move and change, some scientists think it might be possible for a universe to appear from a state with no space, no time, and no things. There is another idea called cosmic inflation. This is a way to describe how the universe grew very fast just after it began. The idea says that in a tiny part of a second, the universe became much bigger. The reason for inflation could come from energy in the vacuum, a kind of energy that is part of space itself even when there are no things inside it. Inflation helps explain why the universe looks almost the same everywhere and why big pieces of the universe are not mixed and tangled. Some scientists suggest that inflation can happen over and over, creating many universes, or that it can make a universe start from almost nothing at all. None of these ideas are fully proven. Scientists are still trying to test them by looking for signs in the sky or in the numbers from equations and models. For example, tiny details in the cosmic background radiation might show what happened at the beginning. Some patterns could match what inflation says. Other patterns might fit quantum fluctuations or string theory. With the tools they have now, scientists look for small differences in the light that comes from the early universe. They study how matter is spread out, how galaxies move, and if there are any signs of other universes or different beginnings. Every clue is important. Sometimes the evidence points in one direction. Sometimes it shows new puzzles that make people change their ideas. Even with all these different pictures, some scientists think that it does not really make sense to ask how nothing becomes something, because if there is truly no time or space, there is nothing that can happen. In this way, the question itself might need a new way of thinking. If time starts at the first moment, there can be no before, and so the universe's beginning is not like any other beginning that we know. Because the rules about the biggest things and the rules about the smallest things are not yet put together into one complete theory, many mysteries remain. Some scientists try to build new kinds of mathematics that can describe both small quantum events and big things like space and time. This hope for a single, simple, perfect explanation guides much of their work. Scientists are also interested in whether the nothing that came before the universe is really totally empty, or if it is a special kind of nothing that has rules and possibilities built into it. In quantum physics, even the vacuum is not truly empty, but a place full of potential. Tiny changes can appear for a very short time and then disappear again. These are called virtual particles. Some people believe that every universe might begin as one of these strange appearances, growing into an entire universe if the conditions are just right. The search for ways that nothing can become something uses both ideas and measurements. Scientists try to connect their theories to what is seen in the universe. They use computers to make models, write equations, and match them to observations from telescopes or satellites. If a theory works, it can explain what people can see. If not, scientists think of new ways to describe or new measurements to take. Another idea is that there could be cycles of universes. In this picture, one universe ends, and after some very long time, another begins. The two never touch, but the end of one could make a place for the start of the next. Some scientific models use this idea to try to describe why the universe started with certain properties. It is still a big question with no final answer. Some scientists ask if maybe the universe did not start from nothing, but always existed in some form, with no first instant. Others suggest that the universe began as a very simple state and then changed and became more complicated. Some ideas say that the laws of physics themselves can change over time, and that a new universe could have new laws, new particles, or new types of space and time. One more idea is that information, not matter or energy, could be the basic thing that makes up the universe. If information is the starting point, then a universe could begin as a pattern and then grow and become real matter, energy, space, and time. Scientists use very complex mathematics to study this, and it is not easy to test, but it is one more way people are trying to answer the question of beginnings. All these ideas show that scientists are searching many different paths to explain how nothing can become something. They use clues from light, from the arrangement of galaxies, from the shape and patterns of cosmic background radiation, and from the tiniest particles. Each idea brings more questions, but also more understanding. People also use big computers to test which ideas can work. They put different rules and numbers into the computer, make a pretend universe, and watch what happens. If the pretend universe grows and changes in a way that matches what is seen with telescopes, the idea might be close to what really happened. Testing these ideas takes time and patience. Sometimes new data from telescopes matches one idea but not another. Sometimes the data shows something strange that cannot be explained yet. Every new piece of information is a step forward, even if it adds a new puzzle or shows that an old idea was not correct. Even though the origin of the universe is a deep question, scientists and people everywhere are trying to understand it. The search is about more than just facts or numbers. It is about curiosity, wonder, and the desire to know where everything comes from. The search also helps people think about their place in the universe. If the universe can come from a quantum fluctuation, or as one of many universes, or from a new law we do not know yet, then maybe everything that exists is part of a much larger story. Some answers may be found in science, others in new ideas, and some may take many years or even centuries to discover. Scientists keep working together, sharing what they find. They build new telescopes and better computers, and invent new mathematics to help push the search forward. Every discovery about the first moments of the universe helps answer a part of the question and makes the mystery of how something can come from nothing a little less impossible. There is still much to learn. Each possible answer leads to more questions, but every new step brings more understanding about how the universe might have begun. The journey of searching is as important as the answer itself, because it shows just how much people can learn by being curious and by working together. As the search for answers goes on, people look deeper into the universe, gather more data, and think about new ways to test old ideas. As more discoveries are made, the hope grows that one day there will be a clear answer to how everything started and how nothing can become something. Until then, each idea, observation, and experiment brings science closer to this great goal. Scientists and thinkers continue to search for better answers about how everything started. As ideas change and more information is found, some experts suggest that the question itself might be the real problem. They point out that trying to ask what was before the universe may not make sense at all. In science, many discoveries have shown that the words people use every day do not always fit when talking about things like the beginning of the universe. This is especially true when time and space themselves are part of the question. One key discovery from the study of the universe is that time did not always exist. Time started when the universe began. There was no before in the way people usually understand that word, because time itself started with the Big Bang. If time did not exist, then there is no way to talk about something happening earlier or later. There is not a place or a moment that can be described before the beginning. This idea is difficult because people live inside time. Everyday life has a clear past, present, and future. All language, thinking, and science use time to organize events and understand change. People talk about what happened before and after, and they expect every effect to have a cause that comes earlier. But if there was no time before the universe, there cannot be a before at all. In this sense, asking what happened before space and time is like trying to step outside the only way people know how to think. Many scientists say that the universe is everything there is, including time and space. The beginning of the universe is also the beginning of time. The Big Bang is not just an event happening in time, it is the start of time itself. There is no clock that was running before the universe existed. There is no earlier period that can be counted in seconds, minutes, hours, or years, because all those ideas require time first. Because of this, some experts believe that questioning what came before the beginning is a mistake. It is not just that people do not know the answer. The real problem is that ordinary questions do not fit the situation. Time had to exist for before to have a meaning, and time did not exist when there was nothing. This is a very strange and new way of thinking. It goes against what feels normal for almost everyone. Still, it matches the lessons learned from physics and modern science. The mathematics that explain space and time show that both started together at the Big Bang. If someone asks, what is north of the North Pole? There is no answer because the North Pole is the top. In the same way, before the beginning of time has no answer because time itself started right there. This way of looking at the universe challenges all the usual ways people want to find causes for things. It is normal to think every effect must have a cause, and every cause must come before its effect. But the beginning of the universe is different because cause and effect are ideas that only exist when time exists. Without time, there are no causes and no effects, just the start of everything. Some scientists try to say this by explaining that the laws of physics, as known today, only work after time and space begin. The rules people use every day, and even the special rules of science and math, all depend on having space and time to work in. If there is no space, there is nowhere for things to be. If there is no time, there is no way for anything to happen, begin, or change. When people ask about the cause of the universe, it is possible that the answer is simply that there does not need to be a cause outside or before because there is no outside and no before. The moment the universe appeared is the moment time itself began. Science finds this idea difficult, but the evidence points to it again and again. This way of thinking also means that the universe does not need something outside of itself to start. Some people used to believe there had to be something or someone who created everything, and that this creator existed before the universe. But in scientific thinking, there is no need for this, because the question does not fit the facts. When no time exists yet, there is no waiting, no action, and no process, just the appearance of time and space together. This is why some scientists say that the start of the universe is not just hard to imagine, but really impossible to imagine with normal language. The mind wants to picture something happening inside time, but there is no time at that point. The start of the universe is not just another moment in a line of time. It is the very first moment, and there was nothing before it. Even when scientists write equations to describe the first moments, they are sometimes just describing the limit of what time can mean. For example, some equations in physics show time getting closer and closer to zero, the very beginning. but there is no -1 second before time began. The science stops at that first instant, because there is nothing to measure before that. This idea also helps explain why it is so hard to use words like cause or origin when talking about the beginning. The universe does not have a cause in the ordinary sense, because cause needs time and space. Words that are used for ordinary things, like when, where, and how, do not always work when talking about the beginning of space and time. People sometimes ask, if there is no before, how did the universe start? Some scientists say, this is the deepest kind of question possible. It may be that the universe simply is, and that its beginning is not a question with an answer. Others look for new ways of thinking, new mathematics, or new science that could explain this strange event. Some thinkers believe there are better questions to ask. Instead of searching for a before, people can study what the universe was like at the very beginning. This means looking for clues in the earliest light, the way atoms formed, and the patterns that matter left in space. Every bit of information helps describe the universe's first moment, even if people cannot say what came before. Science also helps by reminding us that words have limits. It teaches people to be careful with questions and to notice when questions do not fit the facts. It is possible that human minds never evolved to understand things beyond time and space, because people never need those ideas in daily life. Yet, by using mathematics and careful experiments, scientists can go beyond normal thinking and try to touch the unknown. Even though science says there was no before, it remains curious about why the universe appeared and what makes it necessary for something to exist. Some scientists try to invent new ways of thinking, like using cycles, multiverses, or quantum foam, but all of these ideas still must begin with some kind of time or space. If those things come from the universe itself, it might be impossible to go further back. Some theories propose that time itself could be an effect of matter and energy, not a thing that exists on its own. In this idea, there could be no time when there is no universe. And when the universe appears, time simply begins with it. In this view, asking for a before the universe is like asking for a sound when there is no air. Still, not knowing everything does not stop people from learning. Every discovery about how space and time began is an important step. The mystery is not smaller or weaker because there is no before. In fact, the mystery becomes deeper. It helps people think about why the world is the way it is and why there is something instead of nothing. Some scientists and philosophers suggest that because the question of before does not make sense, the universe might be a self-contained system. This means it needs no outside cause or explanation. All the rules, all the laws, and everything that happens follows from the start of time and space at the first moment. The universe just is, with nothing outside of it. Other thinkers say that maybe there are deeper truths about reality that people cannot yet reach. Maybe the universe is part of a pattern much bigger than what people see now. Evidence for this might come in the future, or maybe not at all. Until then, the best way to speak about the beginning is to say that it is the moment when time, space, matter, and energy started, and not something with a history before it. It can also help to look at how this question leads science and humans to new ideas. When people notice the limits of language and reason, they do not stop thinking. They make new mathematics, build better telescopes, and look for new patterns. Every step is a way to understand more about the universe, even if some questions do not fit the facts. This way of thinking also guides scientists as they look for better models and tests. They know that every measurement of old light, every experiment about matter, and every simulation on a computer must work within the rules of time and space. By knowing that before the universe is not a real idea, scientists can focus on what can really be discovered. This leads to stronger tests and better theories about how space, time, and matter appeared. At the same time, people keep wondering about ultimate causes and final answers. Even when science explains that before is not possible, human curiosity wants to go further. This desire to know more shapes the questions people ask and the tools people build. Sometimes the best questions are the ones that seem impossible. In the search for answers, teamwork is important. Scientists from many countries look together for signs of the beginning. They share data, develop new methods, and try to build a bigger picture of the universe's first moment. Even if nobody can say what was before, they can describe in detail what was happening at the first moment and after. Technology moves forward, and so does knowledge. Every new measurement of ancient light, every map of distant galaxies, and every test of a mathematical theory brings understanding that is a little more complete than before. Each new answer shows how far science has come and also what mysteries still remain. The idea that there was no before the universe helps make sense of the evidence from telescopes, light, and equations. It tells why all clocks in the universe must start together, why all measurements must begin with the Big Bang, and why nothing can be found that happened in an earlier time. This is not just an opinion, it is one of the main lessons from the most respected physics and astronomy. As people keep asking about the start of everything, they also learn something important about themselves. They learn that the universe does not have to fit human habits or language. The universe is bigger, deeper, and sometimes stranger than anything people have ever seen before. By noticing where questions stop making sense, people open up new ways to look at reality and to accept the limits of knowledge. Still, the search does not end. Even without a before, there is much to find out about how space and time began, how matter formed, and how laws and patterns shaped the universe. Scientific discovery moves step by step, using careful words and new tools to describe each layer of the mystery. The lesson that asking about before the universe leads nowhere is not a reason to stop learning. Instead, it shows that some ideas are so deep, people must use new thinking to see them clearly. The beginning of the universe is not only a mystery of science, it is a door to questions about everything, about why the world exists, what it means to be, and how people can explore the unknown. Each scientist, student, and curious person who asks about where the universe comes from joins in the search for answers. The more that is learned about why before makes no sense, the more space there is for new and creative questions. The journey to understand the first moment of the universe invites everyone to think in new ways, use new ideas, and keep looking at the world with wonder. As the search for answers continues, science and technology move together, changing the way people think about the universe. Every day, scientists build new tools, try new ideas, and search for better understanding. Curiosity stays strong, pushing people to look for clues about the beginning of everything. The universe invites people to learn, measure, test, and ask questions that go as far as human minds can reach. Many scientists work together in large groups across the world. They do not work alone. Teams join their skills, tools, and ideas to discover more. These groups use large computers to make models that show what the universe may have looked like at the beginning. These computers can test ideas that cannot be tried in a laboratory. They can make a universe appear in numbers, let it grow, and watch as matter and energy take shape according to the rules chosen by scientists. Making a computer model requires careful planning. Scientists start with some basic rules. These rules can come from mathematics, from physics, or from new ideas that try to explain how the universe works. The computer then follows the rules, step by step, building a picture of what might happen. If the computer model creates a universe that looks like what people see through telescopes, that is a good sign. If not, scientists change the rules and try again. This process takes many days, weeks, or even months of work. Technology has changed the way people explore space and time. Large telescopes on mountains collect light from stars and galaxies, showing more details than were ever possible before. Some telescopes are placed outside the Earth, floating in space to see light that cannot reach the ground. These space telescopes find new objects, look further, and gather clearer pictures of the most distant galaxies and the oldest light. Inventions like radio telescopes and gamma-ray detectors let people see new types of energy from the universe. Each new tool adds one more part to the puzzle, helping explain how things began and how they are changing now. With careful instruments, scientists can measure very small changes in temperature, movement, and brightness. These measures are used to test mathematical ideas and check if the models make sense. Teams of scientists also share their findings. Knowledge travels very quickly today. If a team in one country finds something new, they tell groups around the world. Other scientists read the reports, ask questions, and try to repeat the results with their own instruments. Discussion helps the work become stronger. It also helps new ideas grow, as one discovery leads someone else to think of another question. International projects build some of the biggest tools. For example, one team may make a telescope many meters wide to collect faint, old light. Another group may make a strong computer to test millions of models. These projects cost a lot and take many years, but by working together, countries can do more than one can do alone. Better computers also give new power to science. A single task that once took many years can now happen in a few days. Computers do quick math, make images, and look for patterns in data. Some projects have so much data from telescopes that only computers can sort and study all the information collected by scientists. To see deeper into space, people invent new types of instruments every year. Some scientists study invisible waves like microwaves or X-rays. Others look for signals from new kinds of particles that might not have been found before. Physics experiments done deep underground search for the smallest parts of matter, hoping to find new answers about how the universe works. Science also uses satellites and space probes. These are small machines that travel away from the Earth and take pictures or collect measurements. Some satellites look back at the Earth to study how light reaches the ground, while others turn their eyes to the stars, hoping to see signals from planets or far-off galaxies. Space probes travel farther each year, sending back pictures and information from places people cannot go. When new data from space arrives, teams of experts work together to check it. They compare what they see with what the computer models predict. If the results are not the same, they ask why. Was there a mistake in the measurement, or is there something new to discover? Sometimes an unexpected result will lead to a whole new direction of research. Sharing is important not just for ideas, but for tools. Sometimes, a telescope in one country is given time to be used by a scientist from another country. Teams meet to talk about results, plan new projects, and check each other's work. This sharing of knowledge and tools helps make new discoveries happen faster. Some of the most exciting work involves finding things that do not fit normal ideas. For example, when the universe is measured, some scientists find that matter and energy do not add up in a simple way. The majority of matter may be invisible, a kind called dark matter. The universe might also have dark energy, a mysterious force that pushes space to expand more quickly. Teams look for signs of these strange things because they may help explain the beginning or the future of the universe. Technology has also helped bring science to more people. Pictures and data from telescopes, satellites, and microscopes are shared around the world. Facts about the universe can be learned by anyone who has a computer. Children and students everywhere can see pictures from space, learn the steps scientists follow, and join in the adventure of discovery. With new machines and stronger cooperation, the search for answers moves ahead. Each year, scientists look even farther into space. They discover new stars, new planets, and sometimes whole galaxies that no one has ever seen. When a new discovery is made, it can help explain what happened long ago or show something no one expected. Some teams work to answer the oldest questions, like how the earliest stars formed or how the first moments of space and time changed matter. Others look for signs of life on other planets, asking if the conditions that made the Earth special might exist somewhere else. Each question leads to more work, new plans, and new searches. Even small changes in measurements can mean a lot. If the speed of expansion changes, or the way galaxies are grouped changes, it could point to new types of energy or new laws of physics. Each step is checked and tested many times to be sure that the result is correct. Facing problems or surprises is part of the journey. Not every idea works, and not every search finds what is hoped for, but every failure is also a lesson. It helps teach what does not work, just as success helps show what does. Science is a step-by-step path, sometimes slow, but always open to new ways forward. New ideas also come from better technology. Some instruments can now see much smaller things or much dimmer signals. Other machines can test more rules or simulate more possible universes in less time. As computers grow faster and as instruments become more sensitive, the questions that can be asked become wider and deeper. Many discoveries are made by accident. While searching for one thing, a team may see something unexpected. Such surprises have led to some of the biggest advances. The cosmic background radiation, a key proof for the Big Bang, was found by chance while testing a new antenna. Now, scientists purposely look for signals that might be new or not explained. The work of making new models and testing them never stops. New satellites are planned, and new telescopes are always in development. Some teams try to solve details about how energy moves in the early universe. Others try to find the smallest pieces of matter or the signs left by the first galaxies and stars. It takes courage and patience to keep looking for answers when many pieces of the puzzle are missing. But people do not give up. Every group in every country adds its own skills, ideas, and tools to the search. Some technology helps by making old ideas easier to test. For example, lasers and very clean rooms let scientists check how atoms and particles behave under different conditions. Some scientists work inside large underground labs, protected from other signals, looking for rare events that could explain dark matter. Others send robots to planets and moons, taking measurements of rocks, air, and frozen ice. These clues are used to guess how planets form and if there could be life anywhere else. Each picture and each sample adds something new to the collection of knowledge. Every discovery is checked by repeated tests. Before sharing an answer with the world, scientists try to be sure it is right. They measure in different ways, ask other teams to try, and only agree when several groups see the same thing. This careful work builds trust and helps make science stronger. Questions about the universe join countries together. Space missions are sometimes too expensive or hard for one country to do alone. When people work together, sharing costs and ideas, the results are better and faster. The search for answers to the beginning of space and time is now a global adventure. Young people can join science in many ways, working with data from telescopes on a computer or helping to look for rare signals in space. Schools teach about space, time, and the universe, and new discoveries make headlines everywhere. The dream of exploring space and time is shared by people everywhere. As new information is found, the story of the universe grows richer and more detailed. Long ago, only a few people could ask big questions. Now, anyone can read, watch, or take part, adding to the search for truth. The tools are more powerful, the teams are bigger, and the adventure never ends. Even when questions are not answered, each search teaches something useful. Every failure is a part of the progress. Each new test or measurement helps guide the next step. Science is about always moving, always learning, and always building on what came before. The answers about how nothing became something, or how time and space were first formed, are some of the biggest questions anyone can ask. This journey is long, and there are still many mysteries to solve. With every year, technology grows more amazing and people look deeper into the sky. Plans for bigger telescopes, smarter satellites, and faster computers give hope that new answers will be found. Every day, scientists check their results, share with their teams, and compare what they see to what is expected. The universe is full of surprises. New types of stars, strange kinds of matter, moving galaxies, and signals from things that are still unknown all point to how much is left to learn. The work of building new technology, sharing information, and searching for clues never stops. Teams work to find patterns in the chaos, to see order in what looks random, and to explain everything with simple laws if possible. Each new tool or discovery brings the dream of full understanding a little closer. People in every country are part of this story, learning from the universe, each other, and from the mistakes and successes along the way. This growing knowledge helps not only science, but everyone. It explains where matter comes from, why the sky looks the way it does, and how the Earth became a place where life is possible. The search for how everything began is a story for everyone, not just scientists. The move forward in science and technology is powered by the dream of knowing why there is a universe at all, and what it means for people and all life. Every discovery, every tool, every team, and every question brings people closer to the answers and teaches them more about their place in the grand universe. The path of science is never finished, and each person who asks, searches, and learns is a part of this never-ending quest for understanding. Every new discovery about the beginning of the universe brings new meanings not only to science but also to everyone who wonders about life, about our place, and about the world itself. As scientists, students, and curious people watch the story of the universe unfold through careful observation and hard work, many begin to realize that the mystery of how everything started is not only scientific. This question also touches philosophy, feelings, and the meaning of existence. The need to understand where everything comes from lives inside every person, young or old. This deep question is not just about numbers, stars, or empty space. It shapes the way people see themselves and each other. By following the search for answers, people learn new ways to look at their own place in the universe. They find a connection between all matter, all light, and all time, because everything known came from the same first moment. This makes every person a small part of a much bigger story, a story that goes back nearly 14 billion years and includes all living things, every planet, and every star. Thinking about how nothing became something raises new questions about why there is a universe at all. Why are there stars and galaxies? Why does the world have laws that can be understood and described? Why is there a time at all so that there can be a past and a future? These questions go beyond numbers and reach into meaning, value, and hopes for the future. For many people, learning that space and time themselves came from the Big Bang changes how they see the world. The idea that time did not exist before the universe started is hard to imagine, but it shows that there are limits to what people can picture with words or with simple ideas. When science reaches those limits, it points to the power and beauty of reality, a reality that is bigger than any single viewpoint or story. The mystery of the universe's beginning also helps people see how much there is to learn. It teaches that every answer brings more questions and that the world is always more complex and more connected than it first appears. Each new discovery opens the door to new questions. This process of always reaching for better answers builds curiosity and respect for the universe. Finding out that the universe is very old and has been changing for so long can make the world feel both small and special at the same time. The air, land, water, and even the atoms in each person's body all share a history that goes back to the very first particles formed after the Big Bang. This means everyone is made of the same basic matter, shaped by the same laws and influenced by the same events. This can help people feel more connected to each other and to everything around them. The search for the beginning of the universe is also part of the history of human thought. For thousands of years, people have looked at the sky and asked where everything comes from. They made up stories, poems, and songs that were passed from one generation to another. Today, science joins those stories with new tools, measurements, and experiments. But the basic wonder remains the same. The wish to know is as old as humanity itself. When people learn about the universe, they also learn about how science works. Science is about asking questions, making careful measurements, testing ideas, and sharing what is learned. It is a way of working together to find the truth, step by step, using reason, patience, and honesty. Scientific questions like, how did the universe begin, are big, but so are the questions that children ask every day. Curiosity is at the heart of both. The mystery of nothing becoming something matters for feelings and for society, not only for science. This great mystery gives everyone a chance to feel wonder, to look deeper, and to think about what it means to exist at all. Knowing that the whole universe comes from a single beginning can make the world seem more united and meaningful. It can help people see that everyone and everything shares a common origin, no matter their differences. This idea can also give hope and inspiration. It shows that the universe changes, grows, and surprises, even when the answers are not easy to find. By working together, people can solve mysteries that at first look impossible. This team effort brings countries, cultures, and ages together. Everyone who learns or asks about the universe is sharing in a worldwide adventure. Many people use this sense of wonder to create art, music, or stories, building new ways to talk about the first moments of existence. Some connect their ideas from science to their religious beliefs or personal dreams. Others use it to find hope in difficult times, knowing that even the most distant parts of the universe are connected to every human life. The story of the cosmos belongs to everyone. The mystery of the universe's origin also teaches patience and humility. Answers do not come all at once, and sometimes ideas change as new facts come forward. Science grows by asking new questions and looking carefully for better explanations. This attitude can help in many parts of life by reminding people to listen to new ideas, work together, and accept that mistakes lead to learning. Even when there is not a final answer to how nothing became everything, the search for understanding makes each day meaningful. The process of learning brings joy and helps build stronger connections between people, families, and nations. The mystery is not something to fear, but something to explore. Every discovery about the universe's beginning helps people feel amazed about how much is possible. Planets, stars, life, and even thought itself all come from natural processes started in that first moment. The fact that people can ask big questions, use measurements and ideas, and see the light from nearly the dawn of time is a wonderful result of many generations of work. Every person living today is part of this long, ongoing journey of discovery. Knowing that space, time, matter, and energy all began with the Big Bang also helps people think about the future. Will the universe keep expanding forever, or will it change in a new way? Are there other universes? Does every question have an answer, or are some things always a mystery? These questions are not just for science. They belong to everyone. Asking them helps people work together, dream more, and keep learning throughout life. The mystery of how something can come from nothing challenges all the old ways of thinking. It shows that nature is sometimes stranger than words or imagination. It also shows that science and everyday thinking are deeply connected because the same curiosity drives both. The wish to know where we come from ties together cultures, people, and whole generations. Science also helps people learn respect for the unknown. Instead of pretending to know every answer, well-trained scientists admit what is not understood and keep searching. This attitude teaches openness to new ideas and a willingness to change when new facts are learned. It suggests that everyone can learn something and that questions are just as important as answers. Learning about the universe's beginning can give hope in many ways. It provides proof that big changes can happen, that small things can have great effects, and that limits can be overcome. It teaches that the unknown is not something to fear, but a place where new knowledge can be found. Every question, every idea, and every experiment takes people one step further. The tools used to study the beginning of everything, mathematics, computers, telescopes, and shared ideas, show how much can be done by working together. Children learning today may be the ones who find the next great clues about the universe's history. Each generation brings new ways to measure, to look, and to think. The story never ends. People from different traditions, beliefs, or backgrounds all share this same mystery. Whatever answers are found about the universe's start, these answers will belong to everyone. The universe gives its lessons to all, and the questions about the beginning connect across all the world. The search to understand how space, time, energy, and matter came from nothing is one of the biggest journeys anyone can take. It invites each person to look at the night sky, to ask questions about existence, and to find meaning in the quest for knowledge. Science serves not just to answer, but to inspire. Curiosity about the beginning of the universe teaches people that there is always more to learn, more to wonder, and more to share. The journey is as important as the destination. By walking this path together, people can build a future where knowledge, respect, and wonder are shared by all. The greatest mystery of all, how nothing became everything, remains. It belongs to scientists, philosophers, artists, dreamers, and each person who ever looked up and asked, why? As people learn more about the beginning of the universe, they also learn about themselves, about what it means to exist, to learn, and to be part of a universe full of possibility. The mystery teaches that everyone is a part of something bigger. Every breath, every thought, every moment is linked to the oldest light and the first stars. Understanding this connection can bring comfort, inspire hope, and open hearts to new ways of caring for each other and the world. By keeping wonder alive, by sharing stories, and by searching for the truth, people make the mystery of existence their own. The question of how can something come from nothing is both a challenge and a gift. a sign that learning and hope never end. The universe, born from nothing, has given people a home, a past, and a future to build together. The search for its beginning is a story without a final line, always inviting everyone to look, to question, and to dream.